Bismillahirrahmanirrahim. My name is Sikandar Channar and I am the assistant professor at Government University College, Channar. We will study about the computer architecture. So this is a chapter of first year computer science book. The book is written by Gulshazad Sarwar. So we will follow this book about our syllabus. Before going to the detail of computer architecture, we should be familiar with the word of architecture, especially the word architecture used in constructing a building or constructing a house. Keeping the same principle in your mind, the word architecture involves the things or the devices or the components necessary to make a computer system or the system of the computer. Things may include your computer softwares, computer hardwares that are jointly together to make an interaction of the computer system. What technologies are required to make a computer works? These may be your hardware technologies and software technologies. Now coming to the slide, the internal working of the computer structure and the implementation of the computer systems. In what manner, in what ways these components in the system of the computer are connected. Main thing is to provide efficient interaction or provide efficient environment for the human beings and also for the machines. The architecture also describes the components that are included in the system of the computer perform specific roles. The components include input unit. Examples of the input unit may be your mouse, your touchpad, pointing stick, touch screen, and trackball. Output unit. Examples included in the output devices like the monitors, LED monitors, LCD monitors, CRTs. LED means light emitting diode, LCD means liquid crystal display, CRT means cathode rays tubes, your printers, these are also output devices, plotters, projectors, LCD projection panels, COM devices, computer output microfilm, speakers, headphones, visual display units. Other component is storage unit. Storage unit includes floppy disk drives, hard disk drives, especially now hugely used magnetic strips, super disk, tape cassettes, and zip diskettes. An arithmetic logic unit. Examples of arithmetic operations may be addition operations, subtraction operations, means arithmetic logic unit perform addition, subtraction, multiplication, division operations. And you also perform the logical operations, the logical values, just as not, and, or. These are required in the Boolean mathematics. And the last one is control unit. So control unit is the master of all units that direct the operations, all operations of the microprocessor. It tells the computer memory, arithmetic and logic and input and output devices. How to respond the instructions that are sent by the processor. Now coming to the slide number 2. The slide number 2 is about computer organization. Computer architecture is nothing without computer organization. So what is the organization? This is also word, you have seen this word many times in other fields. Organization of any building, organization of any body. So computer organization is a structure or behavior of the computer seen or felt by the user. Computer organization is the structural relationship among the computer system components, or it tells exactly all units in the systems to how to arrange and how to make interconnection among the components. So organization is based on the architecture. Architecture can't do anything without organization, and organization cannot be run without architecture. The organization involves the physical components like your circuit design, or these are the circuits, tiny lines. So these are data paths. You may see, listen the word buses. So these are the data buses, control buses, means through which processor passes their instructions. So these tiny black parts now are called adders, binary adders. These also perform a specific task. Are signals. So these blue lines are shown because we can't see signals. So signals are shown by these blue lines. This is slide number 3. This is about internal hardware components of the computer system. So these are main components including CPU that we called as the processor, main memory unit, and I/O buses or I/O controllers. All operations are handled by the CPU. What is inside the CPU? Yeah, ALU, arithmetic logic unit, program counter, instruction register. So program counter and instruction registers, these are the registers. ALU is the component of the CPU and also control unit. Memory address register and memory data registers, these are also registers. CPU performs its operations with the help of memory that we call as main memory. And how the CPU got the instructions, that is called as input-output environment. Input. So these are the I/O buses. We give instructions to the CPU through I/O buses, input devices, and these are also accumulators and general purpose registers. These both are registers of the computer system. So we will study about the components functions. What function is performed by each component of the computer. Just go to the back slide, that is slide number 3. Here we see these are the components: CPU, I/O devices, I/O buses, main memory or the memory unit. So what does the processor do? Processor is made up of the control unit and the arithmetic logic unit and several registers. Just remember the contents of the CPU in the back slide number 3. This is the CPU. These parts, arithmetic logic unit and control units, these are the parts of the CPU, and all of the remainings are the registers. The control unit controls and make the coordination among the all other processes. Control unit direct the operations, all of the operations of the processor. Whatever the operations are in the main memory, arithmetic logic unit, input and output devices, and also controller handles how to respond these instructions. So the control unit fetches the instructions from the memory, decode it. Decode means convert into that format that is easily understandable by the processor, and they execute these instructions. Executes means run those instructions, and also perform the operations on the data to synchronize the operations of the processor. Synchronize means, if suppose two distinct processes require the time slice of the processor at the same time. So which process will get the time slice? The processor will not be halted. So there are some scheduling algorithms to avoid this type of this situation. So we arrange the operations in some kind of the manner of the scheduling algorithms. Control unit also handles the other components during fetch of an execution cycle. Now registers. A computer register, a CPU register, or simply we say this register, but in terms of computer science. Don't go to the general life. Is one of the set of data holding values or data holding places. These are the parts of our computer processor. The computer registers may hold an instructions of the computer or the instructions given by the CPU, storage addresses of the memories, or any kind of data. So there are different types of the registers. Processor completes all of its operations by using these registers. Here we have the list of some of the registers: data register, instruction registers, accumulators, and blah 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 blah. So we'll learn about small bit of these registers. Data registers, this is a 16-bit register. So data register is used to temporarily store data being transmitted or from the peripheral devices. This is like a buffer storage. That are parts of our computer processor. anything that is copied from the memory and ready for the processor to be used. Memory capacity of the data register is about 16 bits. We indicate this register by using the symbol of DR in the capital alphabet. This holds the operands of the memory operations. Anything that is copied from memory locations are to be saved in the memory location by using the processor. That is a task of the data register. And then address register, its capacity is about 12 bit. We indicate this capital AR. This holds the addresses for the memory locations. We also indicate this as a MAR, memory of the address register. This register is to use to access the data and instructions from the memory during the execution phase of an instruction. If suppose CPU wants to store some kind of data in the memory, that is to be read from the memory. It processes the locations and it places the addresses of a required memory location in the MAR register or the address registers. And then accumulator register. This is about 16-bit capacity register. Accumulator register is used for storing the results that are produced by the processor or the system. When the CPU generates some kind of the results after processing them, then all results will be stored in the AC register or in the accumulator register. And then instruction register. This is about 16-bit capacity register. We call them as also another name, current instruction register. All the instruction currently being executed or currently being used. Each instruction to be executed by the instruction register hold the instruction until it is decoded till the completion of the execution of the instruction. Then program counter. Its capacity is 12-bit with 12-bit memory register, also called as instruction pointer register. It holds the addresses of the memory locations of the next instruction when the current instruction is executed by the microprocessor. Means it can hold the instruction that is about to turn to be executed. And then temporary register. You can understand this by its name. Temporary means hold the values for the time being. This is about 16-bit capacity register. Input register takes input from the outside environment. Indicate this capital INP or 8-bit register. Output register that displays the processed data processed by the CPU. Means it will hold the results that are processed or that are executed. We indicate this by OUTR. This is also 8-bit register. Arithmetic logic unit and the memory unit. Arithmetic logic unit represented as a digital circuit that performs the arithmetic and logic operations. Suppose addition of two values, subtraction of the values, multiplication of values, and the division of arithmetic operations, comparison of two values, and the bitwise operations. So the bitwise operation means the operations on the bits are the lowest level operations of, suppose the shifting of bits to the left or right. If we shift the bit to the left or right, this will change the whole number. Number becomes lower or higher when we shift the bits. A memory unit. Memory is used to hold the temporary instructions and data for the manipulations. While system is running, when a building or block of code or data that is held in memory, it is directly accessible to the CPU for the manipulation. Means processor directly connected not with the secondary storage but with the memory, means primary memory, that we call as a RAM, random access memory. So this memory, means RAM, is organized into units that we call as a words or word. Word is composed of 2 bytes. Suppose a 32-bit word means it is composed of 4 bytes. 4 bytes means 64 bits, because each byte is composed of 8 bits. So memory unit is divided into units called words. A word is a number of bits that a CPU can process in a single instruction. And we have seen many times the boxes of the processor, that is written in 32-bit processor, 64-bit processor, means the processor can handle the 64 bits of the lines of data at a time in a single process. So each word has its own addresses and sizes. So if suppose processor has a 64 bits of the memory areas, means it will require a higher quantity of the RAM that can handle the data that is generated by the CPU. So now electronic bus or address bus. Address bus is electronic path. So these electronic pulses are the electronic wires which hold the location of the data. Means the data is not resided in these lines, but it transfers the location of the data to be read from or written to the processor, to the memory. Means the data is resided into the memory, the processor reads through these lines, or IO controllers, reads the data through these lines, and data is resided into your memory. The circuit line shows the number of bits it can carry. Means the capacity of the data is dependent on these lines and determine the maximum possible memory capacity of the computer. Data buses. Likewise, the address bus is placed on the motherboard, that we called as electronic pulses or electronic wires. In the same way, data bus is a set of wires that transport data and instructions between the different components of the computer system. So width of data bus is a key factor. So typical data buses are, data bus may be 16-bit long, 8-bit long, 32-bit or 64-bit. Say for example, we already studied that word is a unit of the memory, that is twice of the byte. 2 bytes is equal to 1 word. If a computer has a word of size 32-bit, but with that 16-bit data bus, then the data bus has to fetch the whole instructions of the word in twice cycle from the memory or the main memory. control bus. We call as this control bus is the electronic path through which processor control its commands, its timings, and specific status information about the remaining components. Information may convey by through this control bus. Say for example, save to the memory, or write to the memory, or read to the memory, or send an IO port some kind of data, read from IO port, a request for data bus, means time slice for granting and a data bus, to synchronize the clock pulses. To synchronize the clock pulses means which process will get the timeline of the processor, and resetting all components. These are all tasks are performed by the control bus, and control bus are also placed on these tiny electronic wires or tiny electronic pods. So these are the electronic pods. This is our last slide of today's lecture, input and output unit. Also the last one section, a last one portion of our computer systems, we give the instructions to the input unit for processing, and the processed data is displayed by the processor at the output devices. So input-output unit manages the communication between processor and the input-output devices. Means we give the instructions to the input unit, and the input unit sends the data to the processor with the help of other components, and the processed data is displayed by the output unit. So next one point is IO unit receive the input and request the output from the processor. Then device specific control signal to the device. It also manages the flow of data that is sent to the devices or that are taken from the devices. Thank you.